Good afternoon to the participants. So for the afternoon session, we are having with us Dr. A. Mukhopadhyay, who will be delivering a lecture on designing of sportswear. Dr. A. Mukhopadhyay is a professor in Department of Textile Technology in NIT Jalandhar. He is having academic and research experience span of over 30 years and 2 years of industrial experience. His field of interest is quite diversified and interdisciplinary, which encompasses many areas of technical textiles, such as filtration textiles, medical textiles, geotextiles, and sports textiles, etc. He has contributed more than 180 research publications in the reputed academic and applied journals, conference proceedings, etc. Publications also includes 12 monographs and books chapters, encompasses different area of technical textiles. Till date, he has guided 50 postgraduate student, PhD and MTech scholars on different projects. He has successfully carried out several consultancy projects and has been carried out many sponsored projects supported by DST, CSIR, MHRD, TIFAC, and World Bank assisted projects. He is also involved in several outside institutes, academic work, professional societies, industry, government, public, or community services. He is active reviewer for more than 40 international journals and presently editorial member of Journal of Natural Fibers. He presented his research at several international conferences held abroad at USA, UK, Germany, Austria, South Korea, and China, etc. He had been also scientific committee member and chairperson at many international technical conferences. So I welcome Professor A. Mukhopadhyay, and I request him to start his presentation so that we can gain more and more knowledge about the topic, that is designing of sportswear.
Good afternoon to all of you. Whether I am audible?
Good
Yes,
afternoon,
sir, you are audible.
Yes, it is audible.
I don't know why my video is not. I'm not been able to share my video.
So what is the problem?
I'm not been able to share my video, my own video. Okay, slideshow I can present. Slideshow is visible.
Already you have shared your screen. I can see your screen. Yes, sir, your slides are visible.
My video is not visible probably. It is not active.
Okay, sir, let me. The camera. Sir, you can rejoin it.
Okay, rejoining.
Yeah, you can reach.
Okay. Okay, now it is fine.
Yes, sir. Now you are visible.
The slide is visible or not?
No, sir. Share it again.
Okay. Now?
Yes, sir. Now it's visible. Okay. Yes, sir. It's okay.
Okay, thank you. So good afternoon again. My topic is on designing a sportswear. Now, before I go into the how to design the sportswear, we must have some basic understanding. So I've kept this thing matter simple for our easy understanding. Now, these are the different dimensions of sportswear. If you see the sportswear for active person participation, this is one. And then in today's context, we can also have the sportswear for fashion and sportswear for comfort and leisure. Okay. Now, if the sportswear used for active participation, obviously we must have a proper designing of the sportswear, because the quality requirement could be very stringent in the case of active participation. But on the other hand, the quality requirement will be different if it is for fashion and if it is for comfort and leisure. Now, just look at the leisure sports, marginal condition, active and leisure space. So we can have both active and leisure space in the case of marginal conditions to be considered. Long-term wear time. So one may be in swimming pool for a very long time. One can run for a very long time. So we can have long-term wear time. We can also have the varying climatic conditions. So these are very common things whenever we talk about the leisure sports. Whereas on the other hand, if you look at the professional sports, in that case, we can have the physical maximum performance. So in a given time, the physical performance should be maximum. And then we can have the short wear time and constant climatic conditions. So these are the requirements for professional sports. Now, designing of sportswear involves consideration of many factors. One of the factors is external conditions. We must consider the outside temperature, whether the weather is warm, moderately cold, or very cold, whether there is a rain, wind, or relative humidity. So external condition must be looked at to designing of the sportswear. For example, if you talk about the warming up of the suit for football wear, warming up of the cloth will be different, or garments will be different in India and in UK, because the outside temperature matters in designing of the sportswear. Now, whether it is indoor sports, outdoor sports, that also have influence on the designing of the sportswear. So, in brief, what I can say that external conditions should be looked at whenever we are designing the sportswear. So, there could be very complex situation where you can have windy situation, rainy condition, wind-driven rainy condition. There could be very complex situation under which the sportswear to be designed. On the other hand, if you look at the other requirement, functional requirements specific to the sports activity. If you look at the swimwear has to be designed different way. Okay, it should not be bulky, it should be next to the skin. On the other hand, the football wear is not designed in such a way so that it should be next to the skin. So the designing of the football wear is different from swimwear. So functional requirements specific to the sports activity, that also needs to be considered. Okay, different sports activity needs different kinds of requirements. A physical mechanical requirement based on sports activity, for example, elasticity, touch, stretch, bulk, and weight. All these influenced by the type of sports activity. Okay, if a person is playing lawn tennis, this kind of garments will be different. Sports garment will be different than the person playing football, person playing rugby. Now, protection and additional functionality. Protection and additional functionality means the tensile strength. For example, for football wear, we must have the high level of tensile strength, high level of shear strength, impact strength, because there could be certain level of impact, abrasion resistance. These are some of the additional requirements: antibacterial, odor, absorption, UV protection, low maintenance, good washability, dirt repellency, quick drying, anti-static behavior, and finally it is dimensional stability. Okay, dimensional stability also plays a vital role. Now, in present moment, if you see that many of the sportswear are made out of warp knitted fabric, because warp knitted fabric is more dimensionally more stable than web knitted fabric. If you are having given choice whether it is a warp knitted or web knitted, many places the warm knitted fabric has replaced the wet knitted fabric because it is dimensionally more stable. Now, factors important for engineering materials. If you see, understanding the human physiology. I'm listening a couple of things or slides I've gone through in first lecture. So, human physiology, neurophysiology, this aspect is important. So, understanding of the human physiology is very important whenever you are designing sportswear, not only the sportswear, any other material garment designing, this plays a vital role. And then just now I have said that you need to look at the external condition. Requirement could be specific to the sports personnel, that is also you need to look at. Okay. Now material selection and its development. Okay, so these are very important, which kind of material to be chosen. And then another new concept which is coming up is the air, a key raw material. Although air is simply can be trapped inside the structure, like you can have the hollow fiber, hollow microporous yarn, layer fabric, creating fiber fudge to trap air, but still this is an important terminology that air is used as a key material. Because suppose you need the thermal insulation property, so it is better to trap air inside the structure. So thermal insulation can also be improved by increasing the thickness of the material. Simply by increasing the thickness of the material, you can trap sufficient amount of air inside the structure. So if you can trap air, obviously the thermal insulation will be higher. But the problem in that case is that the water vapor permeability will get restricted if you make thick and thick fabric. Water vapor permeability will be limited. So that's why if it is possible, if you can make some microporous structure inside yarn or fabric, so that would be better in terms of simply increasing the thickness. Because we will have to look at the other performance parameter also. It is not only thermal insulation, but you need to have the higher water vapor permeability at the same point of time. So if you make the material thicker only, so that can provide you better thermal insulation obviously, but at the same point of time vapor permeability will also get restricted. So another area of development is the membrane and coating material. Mostly it is used for the winter sportswear. So where the development of membrane and coating is important, and finishing is another aspect, and designing of the garments. So in brief, if you see that designing of the garments, that if it is cold climate, if it is for ski wear, the zipper is not placed centrally. You can align it some other places, not exactly at the center. We can have flap over the zipper. You can have several ventilation at several places. So the design of the garment also plays a vital role in a number of cases. Because suppose if you talk about the football wear, it should not be too tight because movement of the body parts will become difficult. If it is too loose, then the opponent can pull you back. So you cannot have very loose fitting and very tight fitting. It should be optimal. So the design of the garments also plays a vital role. Now, if you see the skin temperature distribution, so because I am just moving to the first thing, that understanding human physiology, but I will not cover this thing in detail. Only the limited slide and show you on these particular aspects. Like skin temperature distribution, the unique thing is that skin temperature distribution in rest, walking and running condition is not same. Again, at certain places the temperature level will be higher, at certain places it is less. On the other hand, if you see the skin evaporation distribution, evaporation from the skin is also different at different places. Again, for rest person, evaporation will be from one place, walking, then the evaporation, this area will increase. The running, obviously the evaporation distribution is at different places, but obviously the person will evaporate a lot from the sweating gland. Now this basic concept help us in designing the garments. For example, assessment of sports garment using infrared thermography, because that can give us the idea that where from the temperature level evolving or release is higher, or where from you are having more evaporation. So you can have perforation at certain strategic location so that you can evaporate the sweat very effectively. Because as far as possible, sweating in the form of vapor is always good. But if a person is actively involved in a sports and very high level of activity is there, obviously sweat will not be no longer in the form of vapor. So it will be in the form of liquid. So the liquid moisture management become important. So initially it may be in a vapor form, but if a person sweat profusely, then it will be in the form of liquid, and the liquid management become important. But as far as possible, it is better to manage the vapor so that we can get adequate level of comfort during the sports activity. Now some basic understanding like heat flow by convection. Okay. Now convection heat loss will be more if a person is running, because the air movement will take place. But again, a person wearing garment also, convection takes place because warm air will move towards the top. Okay, so there will be again movement of air if a person is standing or simply sitting. Then also there could be heat flow by convection. Conduction heat loss will be there because the person is in contact with the fabric materials and material to air and the skin. There could be conduction heat flow. And heat flow by radiation. Majority of the cases this is not understood properly. Heat flow by radiation could be very high in magnitude because it is dependent on T to the power 4 as a function. It is proportional to radiative heat loss is proportional to T to the power 4. Means temperature difference, whatever could be there, the fourth function of this can have influence on the radiation. So radiation heat flow could be very high level as compared to the convection or conduction heat loss. Now sweating, this is the unique thing that human can sweat, and through sweat it can reduce the temperature of the body. So sweating could be in the perspiration, could be in terms of vapor, it could be in the form of liquid, but by the perspiration, vapor or liquid form, then what happens whenever it goes into the vapor form, latent heat will be absorbed from the body, so body can cool down because of latent heat concept. So that sort of mechanism is not there in many reptiles and many other animals. That sort of mechanism doesn't exist. Okay, so this is the beauty of human physiology, that they can reduce the temperature by controlling the extent of sweating. Sweating is also there during the winter also, but the extent of sweating will be less as compared to summer. Now this is the similar line. This is another slide, the conduction, convection, radiation. This is the dry heat transfer. Okay, this is the dry heat transfer. These three mechanisms are important. Now whenever I talk about the mass transfer, this is basically moisture transport. Moisture transport takes place in the vapor form and in liquid form. As I just mentioned, the vapor form transport is always preferable. As far as possible, we must design a cloth where the vapor form of transport becomes very effective. Now, vapor form of transport is possible by means of diffusion and by means of convection. Convection means whenever the person is moving, okay, again the hot air is moving from bottom to top because of the movement of the air, so there could be convective vapor movement. And diffusion is possible by two means. One is through airspace and through fiber. Through fiber also the diffusion can take place, through fiber. Okay, and through airspace, the diffusion also can take place. But if you look at this moisture transport, basically if you look at the vapor form of transport particularly, then through airspace, role of this passing of the moisture vapor through airspace will be to a high level. Through fiber, obviously vapor can pass through, but the mechanism is very slow as compared to the passing of vapor through airspace. That's why many cases the people predict the behavior of the material or vapor permeability of the material by simply measuring the air permeability. Because otherwise air permeability cannot, whenever you measure the air permeability, air cannot pass through the fiber. Whereas the vapor can pass through the fiber, vapor can migrate through the fiber, but the air cannot pass through the fiber. But this process is slow process. So that's why through air space, you can pass the air, and through air probability, one can have assessment about the vapor flow to the materials. So this is the basic idea that why the air probability is important. Now this is the mechanism of heat and mass transfer. Mass means the moisture here. Okay. Now here if you see the same thing, I am trying to rewrite in different format so that the mechanism is clear to you. So heat transfer, this is the dry heat transfer, conduction, convection, radiation, and liquid water transfer by surface tension of the liquid. Okay. Then capillary effect, and then by chemical composition of the fiber, internal structure, that can also influence the liquid water transfer. Okay, so mechanism is different for liquid water transfer. Dry heat transfer, the mechanism is different. Water vapor is transferred by diffusion of the water vapor through airspace. That is the maximum extent the vapor is transferred to the airspace only. Okay, and this is the absorption, transmission, and deabsorption of water vapor by fiber. So this is by the fiber itself is taking part. That's what I told you, that this process is slow. Through fiber also it can migrate, but this process is slow process. So absorption, transmission, and desorption of water vapor by the fiber. This is a slow process. So this one basically predominant in the case of water vapor transfer to the textile material. This is the another aspect. This is the absorption, migration, and of water vapor along the fiber surface. Okay, so this is more or less wicking behavior. Okay, and lastly, that transfer of water vapor by forced convection. So as because the body parts is moving, okay, so forced convection, the transmission of water vapor is possible. Now, if you see, this is the fabric. The upper one is showing the fabric here, and this is the skin. In between that, there is a microclimate. So this microclimate, role of this microclimate is very important for comfort of the body. Okay, and this is the outside, there is the environment. So in between the skin and the fabric, the microclimate, role of microclimate is very, very important. Now, whenever I talk about the heat balance, this heat balance is very important because this heat balance must be maintained, otherwise the person will die if there is any sort of heat balance, imbalance, either by means of hypothermia or by means of hyperthermia. Either of the two, the person will die because of this lack of heat balance. Now, this is the heat storage in the body. Okay, heat storage in the body. This is the S. And metabolic heat production, that could be high whenever the person is under sports activity. Okay, now this is the mechanical external mechanical work. This contribute the external mechanical work. So there could be heat loss by convection, heat loss by radiation, heat loss by conduction. So there could be heat loss by convection, radiation, and conduction. And we can also have the evaporative heat loss from skin. Okay, and the heat loss from respiration. Suppose a person is in very low temperature. Now, it can also influence the respiratory organ, because whenever the person will inhale, that vapor can move inside the lungs, and inside the lungs the vapor can be condensed in the form of ice. Initially water, and then it will be converted in the form of ice. So next to the lungs, you can have the ice, and the person can die because of the respiration. But one point I like to mention over here, everything is, I am showing you that minus, 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 but it could be plus also, depending on the whether you are in a hot climate or cold climate, and the situation also is important. Like in a running person, the heat production is by means of food, by means of shivering, and by means of muscle work. There could be heat production. The heat loss could be due to the radiation, due to the convection and conduction. Okay, and also heat loss could be due to the evaporation also. Okay, but suppose the person is standing, he is not moving. Then what will happen? Whenever a person is standing, not moving, then the heat generation will be limited. The body heat generation will be limited. The heat production will be limited. Okay, and the body heat will be greater than outside temperature. Suppose outside temperature is T2, body heat is T1. So T1 body heat temperature will be much greater than T2. So the radiation will be from outside to inside. So this is for a person whenever the person is in an active mode. So radiation will be from inside to the outside, but there could be radiation from outside to the inside also based on the situation. Okay. Convection, convection all could be reversed if a person is taking rest. Any question till now? Should I proceed further? If there is no question. Okay. Now for cold climate, we can see that to improve warmth, what we can do for cold climate. Trapping air inside the structure. We can trap air inside the structure so that we can get the thermal insulation. Okay, because of the presence of air, because air can act as a good thermal insulator. Interrupt heat and heat radiation from fiber towards outside. So this is basically heat radiation must be stopped. So how to reduce the heat radiation? If you use the finer fiber is more effective to interrupt the heat radiation from fiber towards outside. So if you are having better packing and finer fiber, that can interrupt the heat radiation in an effective manner. Use fiber of low conductivity. So we can use the fiber which is of low conductivity. For example, we can use the wool fiber which can have the low conductivity for improving warmth. To reduce air permeability, so air permeability must be reduced to improve the warmth. Use of PCM, phase change material, that is also possible. Okay, because it can absorb the heat and it can melt whenever outside the climate is cold. Use concept of heat of absorption. Like the wool fiber, whenever there is a absorption, it can evolve heat. So they use the concept of heat of absorption, that is also possible. And store heat by absorbing sunlight. So we can make the fiber with zirconium ion. Zirconium ion can absorb the sunlight by using the sunlight as a source of energy. So the fabric can be heated to a certain extent. So in a cold climate, we can improve the warmth by this following means. But as I just said, that in a cold climate, if a person is under activity, okay, if a person is involved in high level of activity, person will also face the heat burden. Okay, the body heat of a person will be also at a higher level. So the requirement could be somewhat different if a person is at rest, if a person is at a high level of activity or low level of activity, the requirement will change. Okay, because the body will generate the heat and the person can also suffer under heat stress even if the climate could be cold. Again, I am repeating, even the climate could be cold, the person can suffer from body heat. Okay, heat stress. Because so much of heat can be generated. But the problem is that there is also problem. What is the problem? Whenever the person will take rest, suppose if you are using the lighter garments and whatever, if a person is taking rest, that vapor will be converted to liquid, liquid will be converted to ice, and next to the ice, next to the skin, we can have the layer of the ice. The person can die because of hypothermia. Improving coolness. Suppose how to improve the coolness? So avoid trapping of, it is to certain extent it is just opposite to that of earlier one, cold climate. Avoid trapping of air inside the structure. So we must have higher air permeability. Okay, air permeability must be high to improve coolness. Why the air permeability should not be high here? Because if the air permeability is high, obviously in a cold climate, the person can feel the cold of cold wind, because the cold wind can penetrate through the fabric and it can influence the body temperature. So hot climate, the increased air permeability is the requirement. To interrupt sunlight heat to the skin, that is also required. And to use fiber like material like linen, cotton and rayon, this sort of fiber can be used for hot climate. But again, as I'm mentioning, that if a person is taking rest, the thing is different. If a person is under sports activity, you are having more challenges to make. Now, reduction of sweaty humidity. That is, I'm not mentioned over here whether it is cold climate, whether it is a hot climate. Because in cold climate also a person can sweat a lot, because depending on the person activity. So reduction of sweaty humidity. So these things are important to reduce the sweaty humidity. One is the, yes. Okay, any question? Should I proceed? Any question?
No, sir, you proceed. Maybe someone's mic is on. Just muted it. Okay, sir.
Okay, so avoid trapping air inside the structure. So that is one. Allow heat radiation from fiber towards outside. Okay. Reduction of contact area. So we must make a fabric which can make minimum contact with the body. Moisture transfer towards outside by ventilation. Moisture absorption by fiber, and moisture transfer towards outside. Effective moisture transfer towards outside. Now suppose I am showing this picture. If it is vapor form, obviously the vapor must be able to pass through effectively to reduce the sweaty humidity. On the other hand, if it is a liquid form, the ideal requirement is the skin side that wicking must be less. What is required is that the liquid must flow on the other side very quickly, and there should be wicking on the other side. So this is the requirement, that whenever you want to design the sportswear, toward the skin side, the spreading of the liquid should be as minimum as possible. Okay, because it must propagate to the other side very effectively. On the other side, by means of wicking, it must spread out over a larger area, so that the drying will be also quick. If the drying is quick, obviously there will be effect of pumping, and by means of this, so liquid from this side to other side can move effectively. So these are some of the engineering concepts. Okay, now I am coming to, these are some of the basic concepts we must look at before going for few developments to enhance performance of sportswear. We'll see in a few slides, next few slides, how to enhance the performance of the sportswear by designing of the sports garment in proper manner. If you see the fabric development, there are three parts. Basically, if you see, we are looking at the stretchability and compression. We are also looking at the heat and moisture management. And third aspect is the protection and additional functionality. These are the three broad areas where the developments are taking place. Okay, and based on these three broad areas, fiber development, yarn development, and fabric development, all are coming in the picture. Like fiber development, fiber from different polymeric material. Okay, surface characteristics of the fiber could be different. Hydrophilic surface, that is also possible. We can have the yarn, blended yarn, core yarn, multi-component yarn, hollow yarn. Again, in the fabric structure also, you can have the different types of fabric that has been used. Okay, fabric structure is also modified, stretchable fabric, smart fabric, layered fabric, and different finishes applied, and finally the garment development. Now, approaches towards performance, enhanced performance of the sportswear involve not only fiber, yarn, but fabric and also the finish, garments, everything is important. So suppose if you look at the fiber selection criteria, thermal insulation will be higher and higher if you are going for hollow fiber. Okay. So hollow fiber can give you the better thermal insulation. But the point I like to refer here is that it is not good for wicking. One must think that there will be inside the structure is hollow, but this hollow portion is not effective for wicking. So this fiber is good for only higher thermal insulation. On the other hand, if you look at the next slide, if you are having multi-channel fiber, this is good for wicking. This is not the good for wicking. Although you can have the hollowness inside the structure, but this is not the good for wicking. Now this multi-channel fiber is good for wicking. Again, another type of fiber, water absorbing polymer that can be embedded inside the nylon. Okay, this is known as Hydra structure. This Hydra structure can give you better performance under moist condition because it can absorb the liquid and also the desorption. Because water absorbing polymer is there, also the water get desorption. Deabsorption is also possible effectively for better comfort. So the fiber which is better for thermal insulation, that is not better for moisture transmission. Okay. Again, one should not think that this fiber should be always used for better moisture transfer. Obviously, that is based on the application. For example, for football wear, if you are using this kind of fiber, the strength of the material will be weak. Okay, because football wear you need the very strong fabric. Seam should be also very strong. So what I'm trying to emphasize over here is that you will have to look at all the aspects, not only on a specific aspect when designing a garment for sportswear. Because three things which are important, as I mentioned already, is that external climate, requirement specific to the sports, and third is the other requirement, protection and other requirement. The cotton already it is good for normal activity, day-to-day activity, but normally cotton is not good for sports activity because person will profusely sweat, then obviously the wicking must be very fast. But the cotton cannot perform under that kind of environment. Okay, because this thing will be more clear if you talk about sports wool. If you talk about the sports wool, merino, this is a project done a long back for Manchester United team to develop the football wear on merino wool fiber. But the project was not succeeded. Unfortunately, the project was not succeeded. Although one may think of the 35% water vapor can be absorbed. But the problem is that it will remain in wet condition for a long time because the desorption rate is very, very poor. Desorption rate is very, very poor for wool fiber. So desorption is very slow process. So although the moisture vapor absorption could be 35%, but because of the desorption is very slow process, the wet fabric could be next to the skin for a long time. And the movement of the body part will be again difficult if the wet fabric is next to the skin. It is also possible that elastin fiber can be used. Okay, elastin fiber. Okay, elastin fiber. If you use elastin fiber, that can also improve the wickability in the materials. This is another development, hollow yarn. This is a part of one of my student PhD work. So hollow yarn can be produced in a different way. You can have the core, you can have hollow. Okay, because PVA can be used inside the structure and the PVA can be dissolved after you make the fabric. And 20% PVA is used in this kind of construction. We can also use the blended pre-hollow yarn. Okay, so cotton fiber is used along with the PVA staple fiber. Here the PVA multifilament fiber is used, but here the PVA staple fiber is used. And after you make the fabrics, then obviously you can dissolve the PVA to get the microporous structure. Another structure which is possible is the double tree hollow yarn. So you can use the PVA multifilament to go for doubling, okay, and then you can dissolve this. So by dissolving this, there could be untwisting effect. Because of untwisting effect, so microporous structure can be produced. But out of this, all this structure, our investigation shows that this structure is best out of all this structure. Again, one of the limitation is that PVA is costly. If you are using 20% of the PVA in the mill, they are not allow you to use the PVA costly material and to dissolve this costly material after the end of the process. After making fabric, you are dissolving it. Costly material will go as a waste. So what the industrial people are doing, the industry people are using 5% PVA only, 5% PVA, and they are going for this twisted structure, and the twisted structure they are basically dissolving the PVA to get this microporous structure. Okay, so industrial practices 5% PVA, and in some cases you can also see this kind of structure for making the towel cloth. Now this is the same thing I have mentioned, the double yarn fabrics performing is the best. So if you look at the air permeability, thermal, warm to catch, by considering all this property, double yarn fabric working the best, okay, as compared to other fabrics. Now this is the developed by means of Trident industry. They use the wool fiber in a core, and wool fiber they are dissolving. So by dissolving the wool fiber, you can make the structure porous. Okay, so this sort of structure also can be made for making a structure which will be microporous. This is another unique development, that is the yarn is basically made out of filament, EVAL fiber, and 45% nylon microfiber. EVAL fiber is basically shrinkable fiber. EVAL fiber is shrinkable fiber. So if you are having shrinkable fiber, non-shrinkable fiber, if the shrinkable fiber shrink, obviously the non-shrinkable fiber can form the loops. So basically we are using the combination of shrinkable fiber and non-shrinkable fiber. This is the non-shrinkable fiber. Non-shrinkable fiber will shrink and can produce loops in the structure. By producing the loops in the structure, it can trap air. By trapping air, you can improve the thermal property, thermal insulation of the fabric. Okay, sometimes the people also raise the surface. By raising the surface also, you can make protrusion of the hairs, and the protrusion of the hairs also trap air, and by trapping air also you can improve the thermal insulation property. This is another development by NIT. The normal fabric, if you consider, whenever it is absorbed the water or vapor, then what happens? Normal yarn will swell. Okay, normal yarn will swell and its thickness will increase for a normal yarn, and it can block, it can reduce the pore channel. It can reduce the pore channel if there is a swelling. But here it is just opposite. Whenever there is a temperature and heat, in the presence of vapor, the pore channel will open up. This is just opposite. Pore channel will open up, and as the pore channel is opening up, so heat will move from inside to outside very effectively. So this is a patented technology. Another technology is it is based on biomimics. So the fabric can be made in such a way, the knitted fabric, the structure is such that the layer which is next to the skin, there you can have the larger pore channel, and followed by the smaller pore channel, and there is a branching. Okay, there is a branching also. So pore channel will be larger in size, and gradually it becomes smaller if you are moving to the other side, and there could be branching of the pores. And because of this, it acts like a tree where the water is pulled up by means of cohesion tension mechanism. So by means of cohesion tension mechanism, there will be pulling up of the water from one side to the another side. So this is another development. Another development is the biomimics based on development. This is the transpiration effect in plants. Like stomata open, stomata closed. If there is a vapor, then obviously stomata open. Okay. Stomata can be also closed if it want to retain the water. If the tree want to retain the water, stomata closed. If the plant want to lose the water, for example, in a season where the water can pass through this stomata, to assist that the stomata get opened. So similar structure has been made whenever you are making a fabric. So you can have the opening up on the fabric. That opening in the fabric will be enlarged whenever there will be more moist vapor. So similar structure has been made, and this is the MIT researcher who just made it this kind of structure. So it basically open up whenever it is needed, and it closes whenever it doesn't need. Okay, whenever a person will be in a sports activity, high level of sports activity, lot of heat will be generated, lot of moisture vapor will be generated, then it will get open up. Otherwise, in a normal activity, this will be closed. So similar in the concept here also, like fine foam. So here basically it is not, there is a small flap is being used. So this flap will get opened or closed depending on the whether the moist vapor is more and less next to the skin. Because as I told you already, because microclimate, managing the microclimate is very, very important. Suppose this is the skin side, this is the fabric. So managing this microclimate is very important. So this flap will get open up, okay, whenever there will be more and more heat burden or moisture, so that the person can get relief from the heat burden. Now, functional requirement type of sports activity like the football wear, sweat absorption, fast drying, high tenacity. This is very, very important. Not only the fabric, also the seam. Anti-cling property, anti-static, lightweight fabric, and anti-odor. Okay, so these are the important now next I'm coming to the swimwear. In a swimwear, low fluid resistance. That's why it must fit to the skin. That is one of the major requirements. Now, whenever it is fit to the skin, obviously you need the stretchability, because the skin also stretches up to a large extent. So you must have the stretchability, chlorine resistance property, low moisture absorption property. These are the requirements for fabric for swimwear. So swimwear, so polypropylene fiber is preferred. Okay, polypropylene fiber can be used for making a swimwear. Nylon fiber also can be used for a swimwear. Now this is just to show you the level of stretchability depending on the position of the garments next to the skin. So the stretchability could be at a high level or it could be low level depending on the position. But what is important is that stretchability, whenever I refer to the stretchability, that means at a particular level of stress, what is the level of elongation which is available, or at a particular level of elongation, strain, what is the level of stress is available. Suppose why I am saying all this, because whenever body take a new posture, obviously the fabric will be stretched to a certain extent. So basically it is strain dominated. It is dominated by strain. So certain level of strain is important whenever the body is taking a particular posture. Now what happens if it is lycra, made out of lycra, the level of stress developed on the fabric will be less, but the level of stress for 100% polyester will be very high. Okay, so whenever the level of stress is high, that means the fabric will have more pressure on the skin. If the level of pressure is less, that means it will be more and more comfortable. So it is basically strain dominated phenomena, because sometimes it may be stress dominated phenomena, but here it is strain dominated phenomena because it is next to the skin, and because it is next to the skin, so that's why it will stress to a certain extent because of the change of the body posture. Now whenever it will stretch up to a certain extent, level of stress is important. Level of stress in the case of spandex will be much lower as compared to the polyester. So that is why the spandex material, lycra, these are the commercial names, these are being used. And there are different ways the spandex can be incorporated. It could be also bare, but sometimes for cost purpose, the bare lycra is also being used. But it is not very durable, and that can appearance also will be bad because the lycra is white in color. So sometimes the appearance wise also will be bad, but sometimes for cost matter, the people are also using the bare lycra also. But ideally, it must have the single cover, double cover, or also it can be incorporated in a core, or it can be in a multi-filament yarn also, yarn covering also. You can put the lycra at the middle, at the center. So different ways the lycra can be incorporated. Although the lycra can extend up to 100 times, but the fabric can extend. Here it is better to say the fabric. Fabric can extend up to 4 to 7 times. The fabric can extend. 2% lycra is sufficient in number of cases. Okay, for safe retention, for body movement, 2% lycra is sufficient. Although we go for 30% elastin. I am having a sports garment which have the 35% of the lycra along with the nylon fiber. So the elastin content could be very high. It could go up to 30% also, depending on the requirement. And sometimes you can use the membrane also. Okay, membrane, but membrane is stretch membrane. This membrane can be used in a swimwear and in a cold climate, in a cold temperature water. If one is going for diving, for diving suit also the membrane can be used. So it is basically sandwiched in between the two layers of the fabric. So there is the two layer of the fabric. In between that you can have the membrane. So membrane, advantage of the membrane is that it will allow the vapor to pass through, but it will not allow the water to penetrate inside. And again, it is stretchable. That is the advantage of this membrane. You can see that sports activity where stretchability is essential. Okay, in all this activity, we need certain degree of stretchability. Okay. Now, if you see the construction of the swimsuit, neoprene rubber is used so that we can make the swimsuit lighter in weight. It can also have the higher insulation, abrasion resistance, and buoyancy. Lycra fiber is used, mostly replaced raw nylon backing. So the lycra is a good material for making a swimsuit. Now this is another development like seamless and stitchless garment. Okay, that is better, but as compared to seam. This is the skin fabric where, because of the structure of the fabric, it can enhance the performance of the swimmer. But this is not allowed in the Olympic because it will enhance the performance of the swimmer. So that's why it is not allowed in the Olympic. Now, what I'm trying to say over here, that stretchability is one aspect, but if you are using the same lycra, but we can also have the compressional property also. Compression is important in case of compression tights. If you see here, which can enhance the muscle performance. You can see it can enhance the muscle performance, muscle oscillation will be reduced, blood circulation will be improved, okay, fatigue will be reduced by means of muscle compression. So compression tights can be made by means of lycra again, lycra in combination of other fabrics. It is fiber. It is possible to have the compression tights. So I am moving over from stretchability, that is one aspect, to compression property. Here also the lycra is used. Stretchability is also lycra is used, but here the structure is different. Okay, than the stretchability purpose. The structure is different. Like here, if you see the cycling wear, compressional sports wear is essential for cycling wear. For athletes also, we can have compressional tights. Okay, here you can use the compressional tights for athletes to enhance the performance of the athletes. We can also have the compressional garments for ski wear. Okay, to enhance the performance of a person. Now coming to the ski wear, this is the requirement. So before I move forward, I am giving you the time for 5 minutes time to think over this, because so far I have told you enough matter on this. I don't know how far you have got this matter. If you have any question, you can ask me. So then I'll start this one, ski wear, and I'll end up with some research work on this particular area. Any question from your side?
So there are two questions in the chat box. First one is, what is W by M2 in heat balance equation? And second one is, someone is asking about Vaishali, that, sir, can you please specify the material according to the region?
Can I?
Can you specify the material according to the region? They have mentioned it.
According to the sports or according to the region?
Region.
Okay. Okay, this equation you are showing?
Yes, sir. The heat balance equation. Yes, sir.
This is the heat balance equation.
Yes,
which one is not clear?
So they are asking about W by M square, which is, I think this is a unit of it. W by M2.
No, W is different. W is external mechanical work.
Okay, so in the chat box, you can see they have written W by M square.
Chat box.
Dr. Janmay Singh, you can ask.
Where is the chat box?
For recent. And so one more question is.
Also can ask if they are having any question. Person also can ask.
Yeah. Dr. Janmay Singh Hada, you can ask. So there is another question from Manpreet Mansai. What type of material is appropriate for active sports in winter like ice hockey?
Ice hockey.
Yes, sir.
Okay, so I'll come back to it because I am having slides on this.
Okay.
First of all, I'll cover this one. Any other question?
So the question was of Vaishali, that she was asking that what are the material for according to the region? Specify the material according to the region. That's all. We have only 3 questions.
As I just told, that you need to consider the type of sports activity also. It is not that according to the region, all sports activity can have the same material. It is not practically feasible. You're getting my point? So you'll have to identify the type of sports activity, because certain sports activity needs different type of material than other sports activity. Okay, so region wise you cannot fix which kind of materials can be chosen. Only the thing is that if there is a no sports activity, the kind of materials which can be used, that can be discussed. Because if the person is under sports activity, whole things will go on changing. As I said, that even in cold climate, the person can feel the heat stress. Even in cold climate, the person can feel the heat stress if a person is involved in sports activity. So his requirement will be changing, okay, depending on the type of sports activity. Now the point here is that suppose outside climate is hot or cold. So if you are having the linen fiber, cotton fiber, you can manage it. If outside the climate is cold, obviously, sorry, outside climate hot, then you can have the linen fiber. It is one of the good fiber to manage that temperature. Okay, so linen fiber, cotton fiber, that can be used. Outside climate is cold, you can use the wool-like fibers. Okay, wool fiber is not giving you the thermal comfort because of wool fiber alone, because it basically trap air inside the structure. Okay, trapping air inside the structure helps in getting the thermal comfort. So what I'm trying to emphasize over here is that better you should take it as a task, because it is an workshop. Although if you would have been present over here, I could show you some of the sample and the fabrics for different types of sports activity. Okay, but now at this moment it is not possible. So what I'll advise you that you can identify any sports activity, for example, athletics or some different type of sports activity, and based on the sports activity, start thinking what type of requirement is there. First of all, okay. Requirement, what could be the extended temperature? For example, Tokyo Olympic, take the case. Okay, what could be the temperature outside? Okay, what is the requirement specific to the sports activity, for example? Because hockey will be having the different kind of hockey playing will be requiring different type of sports material, okay, than the javelin throw. Okay, the requirement of the material will be different. Okay, then you'll have to identify what sort of requirement is there specific to the kind of sports and other requirements. Other requirements means the tenacity, okay, like whether you are having auditory, whether easy to wash, whether it is lighter or not, whether it is soft to touch. So this sort of requirement, first of all, you think of. Okay, then you try to think that to fulfill this requirement, what kind of fiber to be used, what kind of yarn to be used, which kind of fabric to be used, how many layers you should use. Remember that whenever you are going for sports activity, one must feel little colder. Okay, so that the activity, if you are going for activity, that will balance this heat, okay, to certain extent. If you feel warmer, whenever you're putting on cloth, and if you start having some sports activity, that is not good. Whenever you're going for any sort of sports activity, one must feel little cold. Okay, in a cold climate, I am saying. So that certain degree of heat balance will help you. Okay, so this will be your task. Okay, because I like to see if you have been able to identify certain sports and lot of literature are available, things are available in the internet, and like to say is that there is no uniformity. It is not that one will work as the best. It is not like that. Don't think that, don't get hesitated by thinking that, okay, this combination will work best. Okay. Otherwise, every manufacturer would have gone for the same structure, same everything. Different manufacturer is having their own level of thinking, they're having own level of understanding, and different sort of structure have been developed based on different type of activity. Okay, it is not that you can think of something different also, no problem. But I like to see that what is your level of thinking on this. Not only this, you should think of the GSM also, what sort of mass density of the fabric should be available, what should be the strength, what should be the other quality characteristics we must look at. Okay, so make it as a project and then you can also submit it under this platform.
So there is another question from Dr. Kamal Raj. He's asking that what should be the fiber for the football player garment design?
Okay, football player primarily it is polyester fiber. Okay, and this is a micro denier fiber. Fine fiber are being used. Okay, why finer fiber? So that we can have better wicking. There is a logic that why finer fiber, because there will be high level of wicking which is possible by taking the finer fiber. Not only finer fiber, the cross-sectional shape should not be circular. Okay, there should be multi-lobe structure, and so that the wicking could be done very effectively. Other requirements are this: the whatever the fabric you make, fabric must have very high level of strength. For example, rugby, football, it needs high level of strength. Okay, so the fibers should have high level of strength also. Okay, because you measure the stress strain behavior. See, the polyester fibers are available in different stress strain behavior. Polyester fiber, which is used for example, tire cord, they are having the different stress strain behavior than the polyester fabric fiber, which is used in the normal apparel fabrics. Their stress strain behavior is different. Okay, so different characteristics of polyester fiber, finer fiber, different shape fiber, this will help. Okay. Should I proceed further?
Yes, sir.
Okay. Now, if you can see the ski wear, again you can see that requirement is the vapor permeability. This is one. Waterproofing. Vapor permeability is easy to achieve. Vapor permeable, but most of these cases, this comes with this waterproofing. Waterproofing means it will not allow the water to penetrate, but it will allow the vapor to pass through. Okay, so this is a challenging task, because that's why the membrane is made in such a way that it will allow the vapor to pass through, but it will not allow the wind to penetrate, it will not allow the water to penetrate inside. Low air resistance, this is another requirement. So fabric must have bulky, should not be bulky. If the fabric is bulky, then obviously air resistance will be high. If the fabric is bulky, air resistance will be high, movement of the person will be difficult. Sunlight absorbing and thermal retention, these are the important aspects. As I already mentioned, that zirconium ion can be used for making a fiber, and this can absorb the sunlight. So thermal retention is also very important. Now see the construction, polyamide. Okay, polyamide fiber can be used. Okay, polyester also can be used. And lycra becoming inevitable most of the cases. Lycra. Okay, lycra is inevitable most of the cases. Then PU coating. One point I'd like to mention is that PU coating is around 60 to 67% most of the cases. Okay, PU coating is able to stretch. That is the advantage of PU coating. Now these are the points which is important. Which are important is that greatest threat is the water accumulation within the airspace. That is the greatest threat. Why that is the greatest threat? Because water can have the conductivity which is 25 times to that of air.
नहीं ਤੁਹਾਡੇ ਸਾਡਾ
Any
ਜਿਹੜਾ
question?
ਜੁਆਇਨ ਟੂ ਡੋਰਮੈਂਟ ਹੋ ਗਿਆ ਮੈਂ ਤੁਹਾਨੂੰ ਕਾਲ ਕਰੀ ਜਾ ਰਹੀ ਸੀ ਕਿ ਕਿੱਥੇ ਹੋ ਇੰਸਟਾਗ੍ਰਾਮ ਜ਼ੂਮ ਕੀ ਤੇ ਮੈਂ
There is some noise.
Yeah, sir, there was a disturbance. I've just muted her.
Okay. Now, an overcloth person will thus perspire and lessen the effectiveness of clothing. Peeling of extra insulating material is thus desirable for reducing heat buildup. So, if there is a heat buildup, extra material can be removed. Now, you can see the inner thermal wear. Okay, so thermal properties, stretchability, sensory comfort, these are all required. So that's why you need the lycra also. And polyurethane is basically the actual name is polyurethane, but lycra and the spandex, these are the trade names of the company. Lycra is the trade name of the DuPont. Now you can see the multi-layer garments. In a multi-layer garment, because inner side you can have wear this, and then you can have the jacket. In a jacket, outer material can have the water repellent finish. Okay. Then you can have the membrane. Obviously, the membrane is also supported by a fabric. Although I have not written the fabric, but membrane cannot be used as such. Membrane is supported by a fabric. Now here you can see that at certain dots the membrane are being attached to the fabric. So you cannot use that hot melt adhesive. These are known as hot melt adhesive, cannot be used all over surface. So it is attached at a certain dots. So the membrane comes along with the fabric, and this material is imported from abroad. Many places the membrane manufacturer are very limited. Okay, in India do not have this membrane manufacturer. That's why this is imported from abroad, particularly the PTFE membrane manufacturer. Okay, there is no PTFE membrane manufacturer, and this PTFE along with this fabric comes from abroad. So this can be used just after the outer fabrics. And membrane is never being exposed. Don't think that membrane is used on the outer surface, because the membrane will get damaged if it is used on the outer surface. Sometimes this layer is not there. Sometimes this layer is not there. So in that case, what happens? You can have the fabric and the membrane is on the inner side. You can have the membrane on the inner side and the outer fabric is here. Okay. Why this sort of materials are being used? Because if there is a rain, for example, what will happen? If you are do not have the water repellent fabric, in this case, what will happen? The outside fabric will absorb the water, although the water will not pass through the membrane, but the outside fabric will get wet. Okay, it will become heavier and it will absorb water. Okay, but in this case, what will happen? After a certain degree of rain, it can manage because the fabric will not absorb the water. So additional fabric can be provided over here on the outer material so that the fabric will not wet, and after wetting the fabric weight will not get enhanced. Then we can have the insulation, okay, and then lining. Lining could be the next to the skin. Role of this lining material is very important. So as I mentioned that whenever it will come in contact with the sweat should not propagate. It is better that it must have the higher cross-plane property and it must come to the other side. And the vapor should be able to pass through the fabric effectively. But this is one of the combinations, remember that. Because there could be many combinations, as I said earlier, that it is not that there is only a unique combination, but there could be many combinations which is possible. Sometimes there may not be any insulation. There may be membrane, fabric, and finally you can have the lining. Okay. And sometimes there may not be any membrane. There may be only fabric, then insulation, and then lining. So what I'm trying to say over here, it is not that this sort of jacket construction is everywhere. This sort of jacket construction is used. Jacket construction, everything depends on the external climate. If the external climate is 0 degree, you need a different kind of jacket. If it is minus 35 degree, you need a different kind of jacket. So the jacket construction will be different depending on the external condition. If there is no rain, obviously you do not to have the durable water repellent finish fabric on the outer material. So external climate plays a vital role whenever you are making this sort of jackets. But nowadays you can see that either one can use the membrane or insulation material in the case of soft breathable fabric, that is known as soft breathable fabric. So this is the PTFE membrane film, and the porous will be more durable as compared to membrane. So this is the coating. Coating will be more durable than membrane, but the moisture vapor transmission through coating will be relatively less as compared to membrane. Now this is the hydrophilic surface layer. So here the mechanism is different. Here that salt particle, whenever we sweat, that can block the pores, but here it is migrated through diffusion mechanism. Water migrated through diffusion mechanism. Now typical breathable fabric, there could be many typical breathable fabrics. Okay, I'm not going into this because of the time constraint. Now I'm quickly going through some of the slides showing you the athletes. Some of you have asked about the material, but here you will get some idea about what are the requirement, what are the desirable property. For athletes, cycling wear, okay, essential properties, stretching, recovery, sweat absorption, these are the desirable properties. So these are must. Okay, if you look at the swimming, Okay, 4-way stretch, chlorine resistance fabric, these are must, essential property. And these are the desirable property. If you look at the football wear, moisture management is very important. Okay, high tenacity is also important. Okay, desirable properties are there. So if you look at the various sports activity, you can see the warm knitted fabric are used, okay, for base layer thermal. Okay, base layer thermal. For mid layer fleece, you can use the special fabric or bulky non-woven. Outer shell jacket, you can use the breathable coating woven fabrics. So you can see the use of non-woven, special fabric, warm knitted fabric. Okay, many sort of constructions are there. For running, again you can see the compressional tights. So knitted construction is used for compressional tights. So stretching is recovery compact is important. Tops and legging, the knitted fabric is used. Jogging shorts, woven fabric is used. So sometimes it is woven, sometimes it is knitted. Knitted also is available in warp or web, that can vary. Now football wear, just now one of you have asked me about the football wear. So tops can be made out of knitted fabric and it is preferably by means of warm knitted fabric because it is more dimensionally stable. Tights are made out of warp and web knits. Trouser can be made out of woven fabrics. Obviously, in woven fabric also you can mix some amount of lycra if one want to have the stretchable property. So there is no saturation. Again, I am trying to repeat some of the things. It is not that one design is optimum or best. So constantly the things are evolving, changing. One can think of some new material, new construction. Okay, it is possible. Obviously, you will have to see that whether you need a certain degree of stretchability, whether you need a certain degree of compressional characteristics, what sort of fitting is required, whether it should be light fitted or loosely fitted uh, or lightly fitted. Now swimming, again, depending on the jacket, swimsuits, so you can have the woven knitted fabrics with elastomeric filaments. Now this is a case study quickly because of lack of time, because I've spent sufficient time. I don't know whether you have got the idea, fair idea about how to make the sportswear. So this is again one of our research scholar has done it. So PU coated nylon is used, polyurethane coated nylon fabric. So nylon is used over here, okay, not polyester. Middle layer can be used as a polyester fleece or special. So two types of material is used. Sometimes fleece is used and sometimes special fabric has been used to check the performance. And there is the inner layer, which is the next to the skin. Inner layer is polyester plain knitted fabric is used as a inner layer. So this is the multi-layer fabrics which is used for cold climate. The number of layers can be also increased depending on the extent of temperature. So if the temperature is -40, -45, obviously you need a different number of layers will go on increasing. That may happen. So here the objective was to see the sweat solution, okay, how the sweat solution act differently than that of water, pure water. Because of lack of time, I am just showing you the basic things that unidirectional seam is also prepared, bidirectional seam is prepared. Unidirectional seam performance is better as compared to bidirectional seam. Performance is of this one is better as compared to this one. Except the drying. Drying in this case is better because water can migrate easily from the other side of the fabric. Okay, you have the water coming out of the other side of the fabric very easily. Drying will be better in this case as compared to this case. Otherwise, for all other properties, okay, this one is better. For example, water vapor property, okay, the unidirectional seam is better. You can see it is better as compared to other two. Okay, again, if you see the fleece and spacer performance is better in all cases. Performance of spacer fabric is better than the fleece, okay, because spacer fabric is more voids, having more voids, it is more voluminous, so its performance is better. Now, one of the interesting aspects is that sweat and water, whenever we compare, we have seen that its behavior is different. Although we measure it with the water most of the cases, but sweat behavior is different from this behavior. Okay. Although the difference here could be large, but the sweat, if you are using sweat, difference becoming smaller. Okay, but still the unidirectional fabric, seam fabric is better as compared to other. Now this is the individual layer fabric. Individual layer fabric, if you see, there is a lot of changes whenever you are talking about the multi-layer fabric. Because the PU coated nylon is basically not very effective for water vapor permeability. Although the water vapor permeability of these fabrics are very, very high, okay, very high as compared to PU coated nylon. But PU coated nylon, as because it is having very low air vapor permeability, so it will have impact on this. So overall, water vapor permeability has large impact because of PU coated nylon. Okay, so don't think that if you are using the special fabric, it will enhance, because ultimately this will try to restrict the vapor permeability by a large extent. Again, if you see the waiting time, greater is better or lower is better? Any reply from your side? Waiting time, greater is better or lower is better? Hope all of you are attending. Any reply based on my lecture?
So lower is better.
Yes? Lower is better?
Yes,
Sir, lower is better.
Okay, lower means what? Lower waiting time means?
Sir, if we have more time to become wet, the sample fabric.
Okay. See, waiting time lower means, again coming to this, waiting time lower means what? Less. Higher waiting time means less spreading speed.
Yes, sir. We require more time.
Okay. Lower waiting time means greater spreading speed.
Less time, sir.
Okay, less time. But the point here is that that's why I am highlighted over here inner side. Inner side, basically we need the waiting time to be higher. Inner side should not be wet. Inner side, the waiting time should be higher. Why it should be higher? So that the spreading will be less. Whenever you look at any fabric, if you look at any fabric, I don't know whether the diagram is not there. If you look at any fabrics, I'm just drawing it. So if you look at any fabric, this is the inner side. So inner side, and this is, for example, outer side. Inner side, the spreading should be as minimum as possible. It is better that the cross plane flow must be high, and outer side the spreading should be high. Inner side the spreading should be as less as possible. So the waiting time should be higher because it is on an inner side. That's why I am highlighted over here. Getting my point? Because otherwise the wet fabric will be next to the skin. Wet fabric should not be there and the next to the skin. That is the basic idea, that why the inner side, the waiting side time should be higher. But one of the interesting outcome from the research work is that the contact angle is less, obviously the waiting time should be less. Contact time less, waiting time is less. Okay, but here in this case, we have seen that waiting time is more in case of sweat, although it is having less contact angle. Less contact angle means ideally it must have less waiting time, but the waiting time is more, because here if you see that from this to this, okay, angle is lower, but the waiting time is more. Waiting time is less. So this is the unique thing, that is our observation, that because contact angle, usually what happens, contact angle, greater the contact angle, greater should be the wetting time. Okay, like in the case of mercury. In the case of mercury, if it is mercury, then greater the contact angle, because contact angle will be high. So greater the contact angle, higher will be the wetting time. That is the idea.
Yes.
So you should have the high level of correlation coefficient. But here if you see, the correlation coefficient is very poor. Why it is so? Because what happened? It is because it is influenced by gravity also. Gravity also, it is influenced by the gravity also. This is one of the slide I mentioned over here. Gravity and electrical conductance influence the result in moisture management test. Because this machine maker will not tell you that this thing will also have the influence. Again, if you see, one of the basic limitation according to me is that whenever it is measured, the fabric is placed horizontal. But whenever I am using the fabric, obviously, really it will be horizontal. At most places it is vertical. So the gravity will also play a vital role. Okay, but this can give you some assessment, that's all. But most often we try to engineer the fabric by using this tester. But we'll have to be really thoughtful whether what data we are getting from the instrument. Okay. So here, that is why the degree of correlation here, it should be small r, somehow it is coming capital R. But if you look at the cross plane will be better in the unidirectional seam. Okay. Again, in the case of special fabric, cross plane is better. If you see the drying percentage is better in the case of bidirectional seam. So all these explanations are there in the, because there are few papers have been published, so you can see the published work if possible. You can search through this title, you can get the idea, because the logic also been given that why it is so, why it is acting differently. Okay, why the sweat is acting differently than water. Okay, and sweat we are getting the less drying as compared to drying percentage, in this case water, and the relative differences, why we are getting the relative differences for different materials, why unidirectional seam is performing better as compared to bidirectional material. So all this explanation we will get. But from engineering side, what I'm trying to say here is that we'll have to be, we should have open mind in thinking, and most of the cases we become too much biased on the instruments, using instrumental data. We'll have to also think that whatever the instrumental data we are getting, whether to sense that is reflecting the characteristics of the material. Suppose if I'm saying that moisture vapor permeability of this material, okay, for example, coming back to the moisture vapor permeability, okay, moisture vapor permeability of the special fabric is better than this. Now, whether the person is really can identify, can influence his comfort, whether it is perceptible or not perceptible, because instrument can give us some value, but whether it is really perceptible or not perceptible, because morning lecture I also listening that handle and feel of the fabric. Now the point here is that obviously the machine will indicate that this material is different from the other material in terms of their feel. Now whenever the human interaction is there, whether the person can really see the difference whenever it is wiring or whenever it is touched. If it is not being felt, obviously that is of no use. That particular research will have less importance. That is my perception. Okay, because that must be perceptible. Whatever the difference is there, that must be perceptible, because many people do not understand the comfort properly. Particularly in India, many people do not understand comfort, because the majority of the people are below poverty line, because they don't have the idea of comfort. They have the idea that it must be durable for 4, 5 years, 6 years, 7 years. For them, the durability matters. They don't understand comfort. Again, the person at a higher level also, they also don't understand comfort very much. And the person, whenever they are judging the fabrics, obviously the color will have some influence. Okay, it aesthetic will have some influence on the comfort. So there are basically there are multiple ways that it influences the human mind. But whenever you look at the sport textile, obviously the functional part becoming very, very important. Functionality, not the aesthetic part, functionality, whether it is functioning it properly or not. So that's why there is a need of proper thinking that which type of fiber to be used, yarn, fabric, which type of construction is better. Not only that, the fabric, what should be the GSM of the fabric, what to be the strength of the fabric. So I am giving you this sort of projects because you'll be here for 5 days. So you can think in that particular area. At least for 1 or 2 applications for sportswear, you must try to write down the what should be the probable construction. You think that this will work best for this football wear. Okay, so that you can think of, that will be a good exercise for all of you. With this, now I am thanking you all for your patient hearing. I think I have given you enough material. So if you have any question, you can ask me.
Thank you, sir. Any question from the participants? I think there is no question, sir.
Nothing is there on chat box?
No, sir, no question is there.
Okay, should I close down if there is no question?
Yes, sir. So thank you very much for your valuable knowledge on this topic. Yes. So thank you.
Okay, thank you.
Okay, so rest of the participants will join tomorrow at 9:15 for our next session, and the link will remain the same. Okay, now we are having a question, Dr. Kamal Raj. Sir has just left. You can directly mail Mukhopadhyay sir and ask the question because he has just left the conversation. Okay.
Thank you.
Okay, thank you.